What's up, calculus students? Let's do this lesson 3 homework. You have to have understood day 2 to be able to handle day 3. If you don't understand day 2, go back. Make sure you understand it, okay? Because what we're going to do is we're going to place objects on top of our rectangles. These objects are coming out of our paper, okay? And we can see that based on how big our rectangles are, our objects may be bigger. If we're talking about squares, boom, that's what it'll look like. Sometimes we will place objects in the other direction horizontally, and then we have objects coming, horizontal rectangles, objects coming out of our paper that'll have different sizes based on the base lengths. So what we should understand is that the integral being an infinite sum, if we just sum up the areas of the objects, that all have a skinny width, either a dx skinny width or a dy skinny width, then we will get volume. Why? Areas are 2 dimensions times a width, which is a 1 dimension. 2 times 1 will get volumes 3D. Okay? Sum up the areas of the objects, each with a skinny width. Boom, you'll have volume. Now, the area of the objects, though, we have to understand what is the area of the object. If it's a square, you're going to take your side lengths and square it. That'll go in here. Instead of just an integral of top minus bottom or right minus left, we're going to have stuff squared. Let's say we have a triangle whose base and height are the same and whose leg is placed on the region. You'll have 1/2 base times height, but if it's an isosceles triangle, then we're going to be talking about base and height being the same. It'd be 1/2 base squared, so we're going to put 1/2 base squared. We'll talk about putting semicircles. If you have a semicircle, you're going to have a 1/2 pi r squared. We're going to talk about what r is going to be. R is not going to be the base length. The base length is our diameter. We talk about either changing our formula to be a formula with a diameter, or we could just have our base lengths being squared. Okay, so let's go. Here's our region. We are placing objects perpendicular to the x-axis that are squares. Let's just understand perpendicular x-axis versus perpendicular to the y-axis. Perpendicular to the x-axis, straight up and down. Straight up and down, you would like to sum things from an x equals left to an x equals right. That's perpendicular to the x-axis. Sum up a vertical thing, not up and down, but from left to right. Now, if I'm going to go perpendicular to the y-axis, here's the y-axis, this is perpendicular to the y-axis. If I'm perpendicular to the y-axis, I need to sum things up from a bottom to a top. So we need a y equals bottom to a y equals top. Now, what the heck is the y equals bottom and the y equals top? This is the y equals 0. What is the y equals top? It's not y equals 4. Well, the intersection, if I plug in 4 into the square root of x, I'll get y equals 2. 0 to 2. Make sure we have that start. Now, we're going to have our formula, but our perpendicular to the x-axis has a small width dx, x distance, small x distance on the bottom of this skinny rectangle. The bottom of this skinny rectangle is a skinny x distance. So perpendicular to the x-axis, dx. Perpendicular to the y-axis. If I'm perpendicular to the y-axis, here's my rectangle. I hope people aren't confused. It is a rectangle. I know it looks like a line, but it's just a filled-in rectangle. What is skinny about that rectangle? There's a skinny height, skinny y distance. So we're going to sum up stuff times the skinny height to be a volume. Now we just got to figure out what goes here. Well, it's going to be some sort of formula, but it's going to use our base lengths. Now, our base lengths, or like the height of this length, or the width of this length, if I'm talking about this vertical height, we're going to have to use a y equals top equation minus a y equals bottom equation. Now, the y equals top is y equals root x. The bottom is y equals 0. Great. If I'm going to go and use a horizontal rectangle, this width here is an x distance. It's an x equals right, which will be x equals 4, minus an x equals left. Now, what is the x equals left? Well, it's going to be x equals y squared. This is our understanding of if we want x distance, we need x equals equations. And then we'll mess around with what this, there could be stuff here, there could be stuff here based on the objects, okay? So we need x equals 4, we need x equals y squared. We have all of the stuff that we might use. Now let's pay attention. We want to do perpendicular x-axis that are squares. The formula of a square, the area of a square is a side length squared. I'm going to take my base lengths and square it. I'm going to sum up all of my base lengths that are squared. If we're perpendicular to the x-axis, we're looking here. It's got a skinny x distance. We sum up vertical things from an x equals left to an x equals right. What is the side lengths? What are these base lengths? These base lengths are a y equals top minus a y equals bottom. That's y equals 0. This is y equals 0, and this is y equals root x. I tell you to not use a calculator. That means I need you to evaluate this integral. Well, how the heck do I take the antiderivative of that? You simplify. When in doubt, try to simplify. So I got 0 to 4 of root x squared is just x. Take the antiderivative. Don't forget to take the antiderivative. We like to use our calculator a lot in this unit because setup is very important. But whenever we're asked not to, we got to go for it. So boom, we get 8. Now, what's that going to look like perpendicular to the y-axis? Squares. Squares, again, side length squared, or base length squared. I need to sum up perpendicular y-axis, these horizontal things. We sum up horizontal things so that we can cover everything from a bottom to a top. From a bottom to a top, what is that going to look like? From y equals 0 to y equals 2. We'll cover all of my region. So y equals 0 to y equals 2. The side lengths we will talk about need to be squared. And what gives it volume? The skinniness, the skinny heights, dy in this situation. Now, what is the base length? It's these x equals distance. It's an x equals right. 4 minus an x equals left. What's on the left? The left is always this curve. So the left is always going to be x equals y squared. X equals y squared. Now, great question. What if I ask you to do this without a calculator? Well, now you're probably thinking, oh, we got this Vegas situation. We got this square. No, Vegas and undoing Vegas's derivative is not going to work. U substitution will not work. We don't have like an undone derivative on the outside. What we have to do and what we're always going to look to do in these questions is to simplify. Then take the antiderivative. What does that look like? Well, I'm going to square 4 minus y squared. I get 16 minus 8y squared minus y to the 4th. Now I'm going to take the antiderivative. And again, we don't care about simplified answers. We just care about the right answer. I know this antiderivative is big and nasty, but whatever. 16 times 2 minus 8 thirds times 8 minus 1/5 times 2 to the 5th is the answer that you would be able to provide on a free response section, and it's correct. And we can go ahead and check it if we wanted to using our calculator. Let's check the first one. Math 9, 0 to 4 of root x, quantity. Should probably put the parentheses in first. Squared, 8. And then we talked about how you could use y's if you want to. If you're intimidated, go ahead and use y's. Use parentheses, 4 minus. If you want to use y's, but you understand that you could just replace them with x's and you get the same answer. Just don't use y's and x's. Classic mistake. And we get that, which is 16 times 2 plus 64 thirds minus 2 to the 5th over 5. Oops. See, it's like I have faith that I'm doing things correctly. Just did not type it correctly. But what the heck? Oh, plus y to the 4th. Plus 17.0666666. Big money, no whammies. Stop! Oh, shoot. Oh, but I didn't put a minus here. I'm all screwed up with all of my signs. Minus 64 thirds. Okay, 17.0666. Big money, no money, big, no whammies. Stop! All right, there we go. All right, 2 more, and then I gotta teach, and then I'll come back. Erase. Perpendicular to the x-axis. What does it look like to be perpendicular to the x-axis? This is perpendicular to the x-axis. This is a rectangle. You see that base? See that height? That's a rectangle. We're placing semicircles on top of this rectangle. Great. What is skinny about this rectangle? It's got a very skinny x distance. That's going to give it volume if we sum up the areas times that x distance. We got semicircles. Okay. Vertical things like to be summed up from an x equals left to an x equals right. Use your pencil. Show that like up and down pencil. Put it down on your paper. Put it right here. And then start sliding it over. Put it down. And then slide it over. X equals 0 to x equals 4. Now let's talk about semicircles. The area of a semicircle is 1/2 pi times the r squared. What's the problem with 1/2 pi top minus bottom squared? Well, the problem is this is not the radius. This would be the diameter, the top minus bottom. So the whole root x minus 0 squared is going to be wrong. So what we can do is say that's a diameter divided by 2 squared. We could take this and divide it by 2, and that's good. But we talked about in class, and this is something that if you want to use, it's great because it's easier to type into your calculator. You can simplify this formula to be 1/2 pi d squared, which is 1/8 pi d squared. You could type this in, or you could type in 1/8 pi d squared. Okay, so either type in 1/2 pi root x over 2 squared or 1/8 pi root x squared. Let's do it. We're going to get the same answer. It's probably not that hard these days to type it in because we have the fraction button. If you don't have the fraction button, though, I can see how you're going to make mistakes. A lot of people make mistakes with just entering it in. You just don't type it in correctly. Yo, the answer is pi. I should have asked you to do this without a calculator. That's fascinating. If I change this to 1/8, pi d squared. Boom. Okay. All right. I'm going to pause. Finish this later. All right. Perpendicular to the y-axis, height is 3 times a rectangle whose height is 3 times the base. We're back to perpendicular to the y-axis. So important, guys, to have the visualization. Think about a rectangle perpendicular to the y-axis. Think about it being skinnier than this. This is a rectangle. I know it's like, oh, it's a blob, but it's like a rectangle filled in. It's got a very small y as a height. This base length is this x distance. We would take an x equals right minus an x equals left. Then we would sum it up from a bottom to a top to cover all the area. So we're back to 4 minus y squared, where y equals 0 to y equals 2. But we got this rectangle whose height is 3 times the base. So a rectangle's area is base times height, but the height is 3 times the base length. So this ends up being an area formula of 3b squared. So I'm going to sum up my 3b squareds. Times the skinny width to give it volume. The base length is an x equals right minus an x equals left. $51.2. Okay. Next region. Oh, same region. That's it. Perpendicular to the y-axis. Triangle. Isosceles triangle. The area of a triangle is 1/2 base times height. If the base equals the height and we're putting the base down, we're talking about 1/2 base squared. So I will sum up from a y equals bottom to a y equals top. 1/2 my base length squared to give me my areas times their skinny height to give me volumes. X equals y squared. X equals right minus x equals left. Rectangle whose height is 2. The area of a rectangle is base times height. Well, if the height's 2, then I'm going to sum up 2 times my base lengths. You type this into your calculator. Many of you need to practice typing into your calculator. So let's type this into our calculator. Many of you won't. You're just copying this down. Some of you are. Such an important lesson to practice. If you're just copying down, you're going to get to the point where it's like we're doing our practice problems and you're just going to get the wrong answer every single time. And you're like, I don't know what I'm doing wrong. It's like, well, you didn't practice. That's what you did wrong. All right. Different region. Y equals x squared, y equals 3x. When do they intersect? Let's pretend this is a no calculator. Don't divide by x. You're not allowed to. It removes x equals 0. I'd subtract 3x. 0 and 3. X equals 0. X equals 3. What does that correspond to y's? If I plug in 0, I get 0. If I plug in 3, I get 9. Very important to have those numbers. We have y equals distances. We have x equals distances. Should be a plus or minus root y, but we're only talking about the first quadrant, so we'll have the positive root y. Make sure your x's look like x's and your y's look like y's. Okay. Squares. Side length squared. Side length squared. Perpendicular to the x-axis. Okay, what does perpendicular to the x-axis look like? This. Okay. We have this vertical thing. We should sum this up from a left to a right. So we get all of the region. If you go up and down with this vertical thing, it's not going to work. I will go from an x equals left to an x equals right. My areas are side length squareds. It has a very skinny width, dx. That's this length right here. It's a very, very skinny x length. Gives it three-dimensionality. What is the side length? Top minus bottom. I asked you to do this without a calculator. Oh, okay. It's like this Vegas thing. Undo, use U substitution. You can't. Simplify. We'd have 9x squared minus 6x cubed plus x to the fourth. That is my simplification. That's 3x minus x squared squared. 3x times 3x. 3x times negative x squared is negative 3x cubed. Add them again, negative 6x cubed. If y'all can't do this, you better like do it by hand or use the box or whatever. Negative x squared times negative x squared. Okay, anti-drive. Plug in 0, plug in 3. You don't have to worry about the c. Subtract. Don't worry about simplifying. Oops. Three times 3 cubed minus 3/2 times 3 to the fourth plus 1/5 times 3 to the fifth. Make sure when you plug in 0, you get 0. I'm going to double check. Again, if you've never typed this in before, you're not going to get it right. You need an extra set of parentheses, 3x minus x squared. Too many people put the squares on the outside. It's not going to work. You get that? No kidding. 3 cubed times 3, so that's 3 to the fourth, really. Minus 3 to the fourth times 3/2. That's where all that stuff goes. Plus 3 to the fifth over 5. I feel like this is not going to work out, but it does. Okay, perpendicular y-axis squares. Perpendicular to the y-axis. What do we see here? An x length, a very skinny height. This x length is an x equals right minus an x equals left. We got squares. We got a side length squared. Away we go. Sum up horizontal thing from a bottom to a top to get the area. So I go y equals 0 to y equals 9 of side length squared. It's got a very skinny height. That gives it the three-dimensionality. The area is an x equals right minus an x equals left. That's so important. This is this x distance based on a y coordinate. This is this x distance based on a y coordinate. Looks like 2.7. Understanding your calculator is sometimes off. All right. I'll give you both options. Perpendicular to the x-axis, we got x equals 0, we got x equals 3. Sum this up from a x equals left to an x equals right. X equals 0, x equals 3. Semicircle, 1/2 pi r squared, or 1/8 pi d squared. R being d over 2. So I either got 1/2 pi r squared. It's got a very small width, x. It is a y equals top minus a y equals bottom distance. Y equals 3x minus y equals x squared. But that's the diameter. Divide that by 2. You type it using the fraction button. Or 1/8 pi d squared. Just incorporates that 2. I feel like my computer's going to take off. I mean, use the fraction button. It will prevent mistakes. Sometimes I don't use it because I'm used my calculator before. But if you type it in, the other way, there you go. Perpendicular y-axis, a sum from a y equals bottom to a y equals top. Of area is base times height. The base is half the height, so it'll be 1/2 base squared. It ends up being a triangle. Okay, 0 to 9 of 1/2 my base length squared. It's got a very skinny y distance. That's the skinny part of this rectangle. I hope you see it and you embrace it. Okay, very skinny. We sum them up from a y equals bottom to a y equals top. This distance is an x equals distance minus an x equals distance. So that's x equals root y minus x equals y over 3. Plug that into your calculator. Okay, we saw this on day 2, how in some situations you need multiple integrals, in some situations you don't. This is one of those examples. One direction's easy, other direction's bad. Okay, perpendicular x-axis. Let's just put down some vertical rectangles. Well, all of a sudden, bam, I see the whole idea of a top minus bottom base length changes twice, so that as you're summing up, you're going to need multiple integrals. Okay, squares, side length squared. I need an x equals to an x equals. I need an x equals to an x equals. I need an x equals to an x equals. I need all these x's. You don't go from y equals 1 to y equals 4. That would be horizontal. I need to go from left to right. So when does x squared match up with y equals 1? That's at x equals 1. When does x squared match up with y equals 4? That's at 2. When does 7 minus x meet 4? That's when x is 3. When does 7 minus x equal 1? That's when that's 6. So I'm going to have to do from 1 to 2 side lengths squared, small widths dx, 2 to 3 side length squared, and then 3 to 6 side length squared. What are the side lengths? The side lengths are top y minus bottom y. Y equals top minus y equals bottom. The bottom's always 1. So it's always going to be minus 1, minus 1, minus 1. So the top that changes is y equals x squared. This is y equals 4. This is y equals 7 minus x. Okay, you type that into your calculator. If it was perpendicular to the y-axis, everything gets easier because we have consistent c's. Consistent x equals right, x equals left. No matter where you are, the x equals right and the x equals left is always going to be x equals, what is this? Solve for x, add x, subtract y. It's the same, 7 minus y. What is this? This is x equals root y. So consistent right minus left. I'll use the 1/8 pi d squared. 1, 2, 4 is the y equals bottom to the y equals top. Horizontal thing goes up and down to cover area. Painting the fence, what I said in class. We have 7 minus y minus root y. Type that into your calculator. All right. Show you how quickly you can do some of these. This one's tricky. I remember when this showed up on the AP exam. We got a cross-section perpendicular to the x-axis whose area is 1 over x plus 3. This is tricky. They're literally telling you, here's the formula for the area. It's this. Well, you need to sum up your areas times the skinny height. You have nothing else to do besides like, that's it. Understand that, sum up your areas, give them widths, and you get 2 dimensions times 1 dimension to give you a volume 3 dimensions. Bad, tricky question. It's shown up a couple times actually. Has to do with like densities and stuff. But S, perpendicular to the x-axis squares. All right, we need to find this intersection, unfortunately. They don't tell you where it is. This is a good question, though. We didn't have any other questions where you're involved to find intersections, so it's good. All right. Summing up from an x equals left to an x equals right, our squares, side length squared, y equals top. Oh, which one's which? Actually doesn't matter because we're squaring things. We'll talk about that more next class. All right, the e to the x one is the bottom. So g of x minus f of x. Done. I'm not going to type it in. It'd take too long. Same deal here. Perpendicular x-axis, but we need to find the intersection. So this is really like these questions are not tricky. They're just making sure we can find intersections. 2.3. That's nice. That's really nice. Okay, we're going to sum up from an x equals left to an x equals right. Isosceles right triangle is 1/2 base length squared because the base and the height are the same. My 1/2 base length squared. They have a very skinny width. The base length is a y equals top minus a y equals bottom. Boom. If you were going to type this into your calculator, put that in parentheses. Or you'd have y2 and y1, but like make sure you have y2 equals 4, y1 equals f of x.
Which side are we on?
I don't want to do this one fully, so we'll just say there's an intersection at A. You have to find this intersection. We got squares that have to change once we get to the intersection because the height changes. I'm not going to go from 0 to A. Pay attention. It's an x equals 1 to x equals A of the top minus bottom. That's log x minus 0. And then from A to 5, that's this. We have a top minus bottom, which is the 5 minus x minus 0. All right, we'll finish off with this one. Because it's perpendicular to the y-axis. This is perpendicular to the y-axis. We got the horizontal line y equals 6. Obviously, we're starting at y equals 0. We get y equals 2 root x. That's y over 2 equals root x. That is y squared over 4, or y over 2 squared is x. We got a rectangle, height 3 times the length. So the area of a rectangle is base times height. The height is 3 times the base length. So the area is going to be 3b squared. I want to sum up from a y equals bottom to a y equals top. 3 base length squareds, a very skinny width to give them volume. That's this length right here. That's small y distance. X equals right minus x equals left. X equals right is x equals y squared over 4. X equals left is x equals 0. It's day 2, guys. Day 2 again. If you didn't understand day 2, if you're not drawing and understanding where your rights, lefts, ups, and downs come from and why you use them, then day 3 is a struggle. Hopefully day 3 helps you understand more of day 2. You good to go? Day 4 is different, and it's more complicated, and we'll see you then. Later.